Hello guys, welcome to the new playlist of Introduction to Electronic Circuits. So this intro to electronic circuits. Okay. So in this very first video of this playlist, we'll go through the concept of charge and the concept of electric current. So let's start with charge. So why do we have to deal with charge in the first place? Basically, there are three basic subatomic particles. Okay, that is, as you know, electrons, protons, and neutrons. Okay. Now, electrons are denoted by letter E minus. Okay, the minus being not the minus means that it has negative charge. Okay. Protons P are having a positive charge, and neutrons are neutral. So basically, if we were to draw a basic structure of a very basic structure of atom, an elementary level structure, what would be is a dense nucleus with protons and neutrons and negatively charged electrons revolving in circular orbits. Okay. Now this is not how it is exactly, because as per the Heisenberg's uncertainty principle, you cannot actually know where the electron is at a particular time with 100% certainty. So this is not how it is exactly. Okay, we have to consider the wave nature of electrons as well. But this is just to get very rough ideas as to how the structure is. Okay. Now, in a neutral atom, the number of protons and number of electrons are equal. Okay, and basically a charge on a proton is equal to charge of an electron in magnitude. Okay, but if we were to compare the two charges, okay, there has to be a negative sign over here, because the charge on proton is positive and charge of electron is negative. Okay, so there has to be a negative sign, but the magnitude of both the charges is the same. So if we get the amount of protons and amount of electrons as equal, number of protons and number of electrons equal, then the atom is neutral, because neutrons doesn't have any charge. Okay, sorry. So that's the charge. Then if you what is the value of this QP? QP is actually equal to, the magnitude of QP is 1.602 times 10 to the power negative 19, and the unit for a charge is coulombs. It's named after a French scientist, Coulomb. Okay, so QP is going to be this with the unit coulomb. Now QE is going to be same in the magnitude, but just one negative sign. So negative 1.602 times 10 to the power negative 19 coulombs. Okay, so that's the charge of proton and charge on electron. Now there is something known as quantization. Quantization of charge. Okay, so what is this? What is quantization? Quanta means packets. Okay, quanta means packets. Okay. So how this relates to charge? Basically, the charge of a proton is the elementary charge that you can find in the universe. Okay, so any other charge q is going to be a multiple of this charge on proton. So n is the multiple, and this n can have values -3, -4, so on, -2, -1, so can go forever. 0, 1, 2, 3, and so on. But it cannot have values like 1.5, 1.7, 2.3, so on. So it can go from 1 to 2 to 3 to 4, but there's nothing in between. Okay, so it cannot go 1.2, then 1.3, 1.4. No. From 1 it directly goes to 2. Okay, from 2 it directly goes to 3. So that's why it's quantization. It's packets. Okay, from 1 it's a separate packet 2, then separate packet 3. There's no continuity in between. That's separate. Okay, so that's quantization of charge. So you can have 1.6 times 10 to the power -19 coulombs, then 3.2 times 10 to the power -19 coulombs, then 4.8 times 10 to the power -19 coulombs. So that is first multiple, second multiple, third multiple. But you cannot have 1.5 times this charge. Okay, so you cannot have one, or maybe you can have to have 1.653 times 10 to the power -19. It's not possible. Okay, so that's the quantization of charge. Now we'll go to concept of current. Electric current. So electric current is basically any flow of charge. Flow of charge over a span of time. Okay. So this current, electric current, is generated by letter I, capital I or small I, and that is going to be equal to Q, charge, over time, T. But this is usually written as I is going to be equal to delta Q over delta T. The reason being that we usually look at this as a change in charge over a particular time span. So for example, if we have a body that has, let's say, 4 coulombs, and after 3 seconds it has the same body as 3 coulombs, okay, then so there is a change in charge, right? There's a flow of charge. So there was a current flowing, right? So if we were to find what the current was, I is going to be equal to delta Q. So what is delta Q? The change in charge. So what is the change? Final charge minus initial charge. So final charge was 3 minus initial charge was 4 over the time span, that is 3 seconds. So that is going to be 3 minus 4 over 3. That is -1 over 3. And the unit for charge is amperes. So let's talk about amperes for a moment. So charge is current is Q over T, right? So amperes is going to be the unit for charge is coulombs, or the unit for time seconds. So amperes is coulombs over seconds. So coulombs per second is ampere. Now, as you can see, the charge, the current that we got over here is negative. The reason being that the direction of current is actually taken to be opposite the direction of the charge flow. Direction of flow of charge. So let me give you an example. Let's say we have a circuit, okay, we have a bulb, okay, and there is a cell, a source, okay. So this terminal is positive, this smaller terminal is negative. Now electrons in the circuit of course flow from negative to positive, because negative means it has electrons. Actually basically the flow of currents is actually the flow of electrons, right? Because electrons flow, protons cannot flow. So electrons flow from negative to positive, attracted to the positive terminal, right? So electrons flow from negative to positive, but the current is assumed to be flowing from positive to negative. So it's exactly the opposite the direction of the flow of charges. The direction of the current is opposite to the direction of the flow of charge. So, which is why we got a negative sign over here. Okay. So this is just a rough idea. Okay, we're gonna elaborate this idea in greater depths in the next few videos. Okay. I guess that's it for this video. I guess I'll see you guys in the next video. Take care.